Welcome to today's ArXiv CS Digest for March 19th, 2026. We received 737 new computer science papers today across 54 subfields. Let's dive into the top picks. Trend 1 of 5, diffusion, quantum, and robotic control. This trend advances diffusion models, quantum computing, and robotic control for AI-driven management of complex systems. This cluster covers 68 papers. Representative work includes spectrally guided diffusion noise schedules. Score reversal is not free for quantum diffusion models. And the convergence frontier, integrating machine learning and high-performance quantum computing for next-generation drug discovery. Trend 2 of 5, multimodal model evaluation and security. This trend unifies research on evaluating and securing multimodal AI systems, focusing on their capabilities, robustness, and privacy across diverse data types. This cluster covers 155 papers. Representative work includes LV OmniBench, pioneering long audio-video understanding evaluation for omnimodal LLMs. Do VLMs need vision transformers? Evaluating state-space models as vision encoders and tinted frames. Question framing blinds vision language models. Trend 3 of 5, algorithms, security, and mathematical foundations. This trend integrates fundamental algorithms, mathematical theories, and security principles to advance computational understanding and solutions. This cluster covers 181 papers. Representative work includes online learning and equilibrium computation with ranking feedback, $R$ equivalence on cubic surfaces I, existing cases with non-trivial universal equivalence, and robustness, cost, and attack surface concentration in phishing detection. Trend 4 of 5. LLM reasoning, training, and human AI. This trend integrates LLM reasoning, training advancements, and human AI interaction to build more capable, understandable, and collaborative AI systems. This cluster covers 176 papers. Representative work includes Not All Features Are Created Equal, a mechanistic study of vision language action models, FinTradeBench, a financial reasoning benchmark for LLMs, and F2 LLM. V2, inclusive, performant, and efficient embeddings for a multilingual world. Trend 5 of 5, 3D vision, generation, and embodied AI. This trend integrates 3D vision, generative models, and embodied AI for perceiving, creating, and interacting with the physical world. This cluster covers 157 papers. Representative work includes generation models no space, unleashing implicit 3D priors for scene understanding, Matryoshka Gaussian splatting, and cubic discrete diffusion, discrete visual generation on high-dimensional representation tokens. Up next, our first paper out of 5. Transformers Remember First, Forget Last. Dual Process Interference in LLMs by Saurav Chatterjee and Kanik Raj from Thomson Reuters, Bangalore, India. Let's break down its key contributions. This paper adapts established cognitive psychology interference paradigms to study memory in LLMs. This foundational experimental design allows for systematic investigation of how LLMs handle conflicting information and context. The methodology involves comprehensive testing of 39 diverse large language models across various architectures and scales. This extensive empirical approach ensures the generalizability of findings regarding interference patterns in LLMs. The study precisely measures both proactive interference, PI, and retroactive interference, RI, in LLMs. This dual measurement allows for a comparative analysis of how early versus recent information is remembered or forgotten. The paper analyzes RI and PI for correlation, model size dependency, and distinct error modes. This detailed analysis reveals that RI and PI reflect separate memory mechanisms within transformer architectures. Up next, our second paper out of 5, StreamingThinker. Large language models can think while reading by Junlong Tong and Xiaoyu Shun from Shanghai, Jiaotong University. Let's break down its key contributions. This paradigm enables LLMs to reason incrementally as input arrives, rather than waiting for the full context. It mimics human thinking while reading, reducing latency and improving attention to early information in dynamic scenarios. StreamingThinker employs specialized reasoning units that generate chain of thought, COT, steps sequentially with integrated quality control. This ensures that reasoning unfolds in real time, adapting to the incoming stream of information effectively. The framework enforces the correct temporal order of reasoning by utilizing streaming attention masks and precise position encoding. This mechanism maintains coherence and prevents information leakage, crucial for dynamic, sequential input processing. StreamingThinker leverages parallel key-value (KV) caches to decouple the input encoding process from the reasoning generation. This innovative approach ensures true concurrency, significantly reducing overall latency and enhancing the efficiency of streaming inference. Up next, our third paper out of 5, Post-Quantum Cryptography from Quantum Stabilizer Decoding by Jonathan Z. Liu and Akshar Ramkumar from Massachusetts Institute of Technology. Let's break down its key contributions. This contribution reduces quantum stabilizer decoding to an LPN-like problem, incorporating essential symplectic algebraic structure. This formulation is crucial for capturing the quantum nature of the problem, despite introducing challenges for security reductions. We developed novel scrambling techniques specifically designed for structured linear spaces. These techniques are vital for overcoming the barriers posed by symplectic structure, enabling rigorous security proofs for all cryptographic constructions. Up next, our fourth paper out of 5, Uniform a priori bounds and error analysis for the atom stochastic gradient descent optimization method by Stefan de Reich and Arnulf Jensen from University of Munster. Let's break down its key contributions. This work establishes novel uniform a priori bounds for the atom optimizer when applied to strongly convex stochastic optimization problems. These bounds are crucial for guaranteeing that atoms' iterates remain within a finite range, preventing divergence. Building on the uniform bounds, the paper provides the first unconditional error analysis for atom for a broad class of strongly convex SOPs. This eliminates previous assumptions about boundedness, offering a more robust theoretical understanding of atoms' performance. The research further derives concrete convergence rates for atom under various conditions, including with and without L-smoothness assumptions. This provides quantitative insights into how quickly atom converges to the optimal solution for these problems. Up next, our fifth paper out of 5, Measuring and Exploiting Confirmation Bias in LLM-Assisted Security Code Review by Dimitris Mitropoulos and Diomedes Spinellis from University of Athens. Let's break down its key contributions. This study quantifies confirmation bias in LLM-based vulnerability detection. Controlled experiments on 250 CV vulnerability patch pairs evaluate 4 models under 5 prompt framing conditions, measuring detection rates and bias effects.